Hello everyone, this is Abhipreet Aman of Section C, Computer Science and Engineering Department of BIT Bangalore. Today I am going to present on the topic called determination of minimum expression using essential prime implicants. So first we would like to read about the basics, that is various prime implicants in K-map. So here we can see that implicant is a product and min term in the sum of products, that is SOP, or max term in product of sum, that is BOS, of a Boolean function. For example, consider a Boolean function that is f is equals to AB plus ABC plus BC. So here implicants are AB, ABC and BC. Now we'd like to see what prime implicants is. Prime implicants is a group of square or rectangle made up of bunch of adjacent minterms, which is allowed by definition of K-map are called prime implicants. That is all possible groups formed in K-map. We can see that here there are three pairs, that is this is 1, this is 2 and this is 3. So here we can see that number of prime implicants is 3. Now we'd like to know about what are essential prime implicants. So by definition, these are those subcubes or groups which cover at least one minterm that can't be covered by any other prime implicant. So essential prime implicants are those prime implicants which always appear in final solution. For example, we can see that this this pair and this pair are essential prime implicants. So here number of essential prime implicants will be 2. Now the next thing is redundant prime implicants. So by definition, the prime implicants for which each of its minterm is covered by some essential prime implicant are redundant prime implicants. These prime implicants never appears in the final solution. Here we can see this middle one is redundant prime implicants because it's not going to appear in our final solution. So number of redundant prime implicants would be 1. The next thing is selective prime implicants. In short form, we can call this as SPI. So the prime implicants for which are neither essential nor redundant prime implicants are called selective prime implicants. So here SPI. These are also known as non-essential prime implicants. They may appear in some solution or may not appear in some solution. So for example, we can see that here this dark one and the other is this one are two selective prime implicants. We can consider an example where a function f is given. It is in the form of SOP, that is sum of products. So we can see that find the number of implicant PI, EPI, RPI and SPI, that is prime implicants, essential prime implicants, that is redundant prime implicants, and the last one is selective prime implicants. So here we can see that total number of implicants are 1, 2, 3, 4, 5, 6, 7, 8. So total number of implicants are 8. We can guess that, or we can easily find that prime implicants are 1, 2, 3, 4, 5. And EPI, that is essential prime implicants, are 1, 2, 3, and 4. And the redundant prime implicants are 5. So, and this is the summary of that. Now for second function, find the number of implicants, prime implicant, essential prime implicant and redundant prime implicant and the last one is selected prime implicants, that is selective prime implicants. So here we can find that total number of prime implicants are 1, 2, 3, 4, 5, and 6. So total number of implicants are 6. Total number of prime implicants here is again 6, and number of essential prime implicants are here. There is no essential prime implicant, so it is 0. Number of redundant prime implicants is also 0, and number of selective prime implicant is here, it is 6. So the number of selective prime implicants are 6. So now we'll go back to the third example. Here we are seeing that f is given in the form of SOP. Here we have to find number of implicant, that is PI, EPI, RPI, and SPI. So here we can see that total number of prime implicants would be equal to 8. No, actually it is 7. 1, 2, 3, 4, 5, 6, and 7. So it is 7, and we can see that total number of prime implicants are these 1, this one, 2, this one, 3, this one, 4, this one, and 5, this one, and the last one, this one, is 6. And essential prime implicants would be 1 and 4, like that is this one and this one. So we can write the minimum expression or the function's minimum expression as like f equals to 1 plus 2 plus 3 plus 4, or it can also be written as 1 plus 5 plus 6 plus 4. So summarizing all this, we are getting number of implicants as 7, number of prime implicants as 6, number of essential prime implicants as 2, number of redundant prime implicants is 2, number of selective prime implicants is 4. So this is the brief introduction to the various prime implicants in K-map. Now we'd like to go to the prime implicant chart for minimizing cyclic Boolean functions. So here prerequisite would be K-map, as we all know that very well, and implicants in K-map. So what is cyclic Boolean function? So a function is said to be a cyclic Boolean function if there is no essential prime implicant in its respective K-map. So this was the definition, and now we are going to properties of cyclic function. So every prime implicant is of same size, so it's okay. Every minterm is covered by at least 2 prime implicants, which means no essential prime implicants. Okay, having no essential prime implicants means that there exists more than one minimized solution, or you can call that expression, for such functions, which will be further be realized using digital circuits. So the last one is, for a cyclic function, we can have two minimal forms with no overlapping of prime implicates. Okay. Here example would be, find the minimal expression for the following function. So how can we find the minimal expression for this function? So this is, here variables are like w, x, y, and z. So after drawing the K-maps, we can look at it and see what are essential prime implicants, selective prime implicants, redundant prime implicants, and simply implicants. So as we can see in the above K-map, that there exists no essential prime implicants. Okay, here we can use prime implicant chart to solve it easily. So what we'll do is going to see the steps to solve our function using prime implicant chart. Step 1 would be, draw prime implicant chart as below. It is given below. Okay, the horizontal entries denote the given minterms which are mapped against all prime implicants vertically, The square boxes are crossed whenever prime implicant covers a particular minterm in K-map. Now, for example, WXZ prime implicant is covering 13 and 15. We can see that WXZ prime implicant 13 and 15. Okay, therefore corresponding squares are crossed. That is denoted by X. This is the convention. By convention, we can take that X. Whatever we want, we can take that, but here we are taking X. So note that A, B, C, D are variables used to denote all the prime implicants. Here is the prime implicant chart. Step 2 would be arbitrarily choose any prime implicant, check the prime implicant and the corresponding covered minterms as well. Now delete the row of the prime implicant and corresponding columns of its minterms, like it has been shown like this and this. You have to check that and delete the rows and columns that it is covering. Now delete the row of prime implicant and corresponding columns. We did that. In our example, prime implicant A is chosen, which is covering minterms 2 and 10. Therefore, delete the row of A and the columns of 2 and 10. So, the arbitrarily chosen prime implicant in our example A must be present in the final minimum expression. So, we know that this expression should be present in the final minimum expression, which we are going to find in the last. So, the step 3 would be like this. Find all such prime implicants which are being covered by other prime implicants completely and remove their corresponding rows. Okay, since these are all non-essential prime implicants. Okay, we get that. In our example, H is covering 0 and 4. H. Here H is this and it is covering 0 and 4. And B is covering 0. B is covering 0. So it means H is covering all the minterms that are covered by B. So we can delete B. Similarly, D is covering C completely. So delete C. So now we get that C is also going to present in the final minimal expression which we are going to find. So the step 4 would be now follow the standard procedure of prime implicant chart mentioned in the step 2 and 3 and 4, whatever. You can say that mentioned in the sub-steps given below. Find the minterm which is covered by only one prime implicant. So check that minterm, its corresponding prime implicant and all other minterms which are covered by the corresponding prime implicant. If all the minterms are checked, stop the procedure, otherwise go to sub-step 1. So we have to repeat this procedure until all the minterms are checked. Now we'll see second example. Find the minimal expression for the following cyclic function, that is f of x, y, z are variables, and this is given in the form of product of sums. Actually it is sum of products, that is SOP. So this is the required K-map, and step 1 we have to draw the prime implicant chart. So after drawing prime implicant chart, we'll get something like this. Now step 2 would be A is chosen arbitrarily. Now the row of A and the columns of the corresponding minterms 0 and 2, which A is covering 0 and 2, as you can see that it must be deleted, both rows and both columns. Okay, and deleted. After that, after the deletion, we'll get this chart. So step 3 would be, since B and F are completely covered by C and E respectively, hence deleting prime implicants B and F. So we'll delete B and F, and after that we'll get this chart. Now step 4 would be, now follow the standard procedure of prime implicant chart mentioned in example 1, as we saw that Minterm 1 is covered by prime implicant C only, therefore check C along with all the minterms which are covered by it, that is 1 and 5. Minterm 6 is covered by prime implicant E only, therefore check E along with all the minterms which are covered by it, that is 6 and 7. So now since all the minterms, that is 1, 5, 6 and 7 are checked, therefore stop the procedure. So you can see that the final minimal expression will be A plus C plus E. So this was the complete solution and the crux of my topic, that was determination of minimal expression using essential prime implicants. So we have used cyclic Boolean function to get the meaning of how this prime implicant system works, or it is used to solve particular problems using this approach. So thank you. Thank you very much. We'll get back in the next video.